Hey everybody, hope you're doing well today. The purpose of this video is to go over a LAMP stack demo and an overview of how to use Google Cloud, which is again our platform that we'll be using for hosting all of your applications, and to kind of give you an overview of all of this. So hopefully you've read through the materials by now and you kind of are getting a feeling for what a LAMP stack is. It's a pretty standard server-based environment for hosting web applications, comprising Linux, Apache, MySQL, or MariaDB, and PHP. In this class, we're not going to really use PHP too much. I might make you at some point just for fun, but we're mainly going to be focusing on Node and React for the majority of our server and client-side programming. But it's good to understand how to actually set up a server and how to configure it, how to set up your firewalls, all of that kind of um, standard activity when you're launching a web server for the first time. Now, as a caveat, there is nothing stopping you from developing locally on your own machine. If you want to install Node, install your own web server, there's like WAMP for Windows, there's MAMP for Mac. Linux, you would just install Apache. There are a ton of other local host style web servers as well. But for your turning in of assignments, I need it to be up on Google Cloud so that I can visit your pages at any point in the day. Say, if I want to grade at 2 a.m. Anyway, enough overview. Let's actually get into the demo here. So what I've got going on, and let me get that guy going, because first video of the day for me. This is the Google Cloud Console. Now you will see this once you are logged in, once you have redeemed your credits. And if you haven't done that yet, please do that before you go through this demo, because you're going to need credits for this particular semester anyway. But this is, again, your console. This is basically the front page of Google Cloud. It may change, it may look different throughout the semester if they decide to update things. But what we want is the compute engine. Now you can find it usually here. You can also search for it. Here it is. Pop open the hamburger menu, scroll down a touch, compute engine, same thing. Basically, we're just kind of having a million ways to navigate to that. Now, what we want to do here is we want to set up a virtual machine, and this is going to be where you're going to spend the majority of your time in Google Cloud. Now, you are more than welcome to use any of the other technologies that are out there if you want to learn them. There's Cloud Build, Cloud Run, BigQuery, machine learning. There's a whole ton of things out there. Not necessary for this class, but you have credits. If you want to play around while you have free credits, definitely feel free. But again, for the purpose of this class, all we really need is a virtual machine. So what I'm going to do is create an instance. Now, for at least the beginning of the semester, we're going to use a micro instance, which is free if you have one. And if we go over to cloud.google.com/free, we actually see a list of all the different products that are available for free, meaning they're not hitting your coupon. So if we want a free virtual machine, basically we have to fulfill these requirements for, oops, I scrolled down a little bit too far. Compute engine. Here we go. So basically I need to set up a E2 micro instance in US West 1, Central 1, or East 1, a 30 gig standard persistent disk, and we won't worry about snapshotting right now, and only 1 gigabyte of network egress, meaning that traffic leaving your server, meaning you're not running a production site. We're going to use this for now. Later, we may bump up the RAM requirements when we get into running Node and React and things like that, because they're a little more heavy-handed with resource usage, which is something I'll grumble about throughout the semester, don't worry. But we want this E2 micro, is basically what we want to configure and remember. I'll put the link to this in the description as well for you all. So I'm going to call this, I'll have requirements for you when you do your assignment for this particular thing. I call this Frederick's CIS658 instance. Good enough. Labels we're not going to worry about for this class. Region, we want US East 1 because that was the area that we need. Zone we're going to leave as B, that's fine. We didn't have any zone requirements in here. But we want an E2 micro. So that's going to give us 2 virtual CPUs, 1 gig of RAM. Not a lot for a machine, but it's enough to run a basic web server. If you needed to host a site for free forever, this could be one way you could do that. All right, so let's get that set up. And the last thing we need to really change here is our boot disk. So we need a 30 gigabyte hard drive. Basically, you have 30 gigs to play with on this virtual machine. If you are not familiar with virtual machines or VMs, just think of it as a computer that is somewhere else that you're accessing. I mean, that's all servers really are in general anyway. All right, so 30 gigs, and we're going to use Ubuntu in this class. That's my preference. I'm going to pick Ubuntu 20.04 long-term, meaning that this is the latest long-term release supported by Ubuntu. All of the demos will be Ubuntu specific, so you can get used to the command line, you can get used to running a standard server in the Linux domain. If you are already good with Linux and you don't like Ubuntu, feel free to use whichever one you want. Use Debian, use Red Hat. There are a whole list of different flavors. Don't recommend Windows Server. It's pretty heavy credit usage if you go that route. But again, this is what I'll be using. You should translate the commands for yourself if you want to use a different operating system. But that is all we need to do here. So we have our system configured, we have our operating system configured, our hard disk is configured. The last thing we need to click here is we want to allow HTTP and HTTPS traffic. Now we'll come back to that when we talk networking. Basically, we are telling Google to configure their firewall to allow traffic in and out, meaning that their external firewall is not going to block our web server. There is an external firewall and an internal firewall in Google Cloud. The internal is basically going to be on this machine that we're building right here. And I'm going to click create so this can start spinning up. The external one is basically the Google Cloud side of things. So we're going to need to configure both of them to allow traffic. We configured the external just by ticking those 2 little check marks. And we'll come back to that later on as we need. Other things, so this instance, this is for something else. You don't need 2 instances up and running here. And that already spun up, which is good. So we have a server that is live. Couple of things to talk about before we get into installing our stack. In here we see, thank you, an internal and an external IP address. So the internal one is used by products inside of Google Cloud to talk to each other. Think of it like computers behind a network router or a switch or something like that. Basically, this is how we can reference each other locally. So in theory, this instance could talk to this instance via this 10.0 network. The other one is the external IP, which is what you'll be using and telling me every time you submit an assignment. This is basically the externally facing address for your machine. So I could type this IP into my URL bar here, and it would go to that server if I had my web server configured. One thing to mention though is there's this little pop-out button. Okay, so if I click this, it's going to try to go to HTTPS by default because HTTPS is usually the preferred way to configure your server these days. That gives you secured encrypted traffic. We don't have that set up yet. We won't be setting that up for a little while, if at all, in this class. So if you get an error where you can't reach the site, make sure that you change it to HTTP, not HTTPS, otherwise it won't work. All right, it's not working now because we haven't done anything with it yet. But just a caveat, and I'll try to remind you as we go. All right, last thing here is SSH. So this is going to pop open a SSH terminal in the browser so that we can talk to our server. You can configure this to use your own client. You can use the Cloud Shell to talk to your virtual machine. I'm just going to use the browser window for this class. If you want to use something like your terminal or PuTTY or MOBA Xterm or whatever you prefer, feel free, but I am not going to be configuring that. You're on your own for that bit. All right, more actions. We can start, we can stop, we can reset and delete. Reset is basically reboot. One thing to note, If it is on, it is consuming resources and credits in Google Cloud. By setting this up as a free micro instance, we're not being charged for it. But if you set up a machine with more power, you will start seeing your credit statement deplete, just as a warning. So if you set up something bigger, make sure you turn it off when you're done. Otherwise, you're going to have a pretty bad time. So let's pop open SSH here. And we are going to get an SSH window. It's going to connect, and you're basically just going to get a standard Linux terminal. So I'll be back in 1 minute while this gets set up. Okay, and we are back. So we have a Ubuntu terminal here. Let me make the text size a little bit bigger for you all. We get some statistics that we're just going to ignore. I'm going to type clear to clear everything out. And we have our window. Now, a couple of things that are different from your standard terminal. This is a browser window. It's got built-in FTP capability, so if you want to upload or download files. If you want to upload a file, you click the little settings icon here, upload file, and then you pick whatever you want to upload, and then it puts it into your home directory. I can type ls to see what's in my home directory. So if I create a new file, this is just creating an empty file. I do ls, here's my file. All right, good enough. I'm not going to, I'll basically give you the Linux commands as we go if you're not familiar with them. If you're stuck or lost, feel free to let me know, and I'll try to give you some more direction on that. But what we want to do is install a LAMP stack. So I have a guide here, which I will also share. This is how to install LAMP stack in Ubuntu 20. All right, pretty straightforward thing here. And what we want to do, actually, I'm going to make this font a little bit smaller just so that, actually, let's do this. See if that helps. All right. First thing we want to do is update our server. So we want to update all the software packages on it. This video is probably going to be a little bit longer as I'm looking at my timer. All right, so we want to sudo apt update. Yeah, let's make the font smaller. Sorry, I canceled that. Font medium, good enough. It's a video, you'll be able to see it. So first thing, in Linux, you type sudo to run an admin command. So if I want to run anything that's going to configure the system, you need super user permission, which we get by running sudo. So I'm going to run sudo apt update, which we see here. This is going to update my system's knowledge of the repository manager. Basically, it's going to get a list of updates for me. And then I can run sudo apt upgrade to actually make the updates happen. And we see here, these packages need to be updated. Do you want to continue? I'm just going to hit enter. The Y is capitalized here. That's usually meaning that that's the default option. You could also type in Y, but by default, it's going to go. So it will update, and then we're going to install Apache. So this is using the Aptitude Package Manager in Ubuntu. It's very nice and easy to use. One of the reasons I quite like Ubuntu. Type clear to clear out our terminal, and sudo apt install Apache 2. Apache is our web server. This is going to automatically install it and configure it for default usage. And what we'll be doing next is configuring the firewall. So our firewall is the unified firewall in Linux, in Debian-based systems now, and we get that through UFW. So sudo UFW apt list, and we're going to see Apache is now. Sorry about that. I have to blur that out. Forgot about push bullet. All right. So what we want is to open up port 80, which is basically going to be our web traffic port. Now, we could configure it to also open up SSL traffic. We are not setting up an SSL server as of yet. We are only opening up port 80. So what this means is that we are only opening up one port instead of multiple ports. That's better security-wise because you want to have as many ports closed as possible on your web server because those are typical ways for people to attack your server. So one way to allow traffic in is sudo ufw allow in Apache. Rules updated. I could have also done ufw add 80, I think, to do it manually. But if I do sudo ufw status inactive, but that's not true because if I recall, system control status ufw, yeah, it is loaded and running. So if we do clear sudo system control enable ufw, and let's restart it. This is not in the guide. We're just going to restart our firewall, and then if we run this again, should be running. Why is it exiting? One moment. Inactive. Be right back. And we are back. So I had to do a little bit of troubleshooting because I wasn't sure why our firewall was inactive by default. I had to enable it. So that's not listed out here because I assume that it's guessing our firewall's already set up, or maybe this is an Ubuntu 20 change. Not sure. But what I had to do was sudo ufw enable. So I will make a quick note of that. I'll put it in the guide. Otherwise, your firewalls are going to do nothing. So we see UFW status, Apache is allowed, meaning that traffic is allowed through, and life is good. So we have a firewall running, we have an Apache server running, meaning that port 80 is open on our machine. Hey everybody, just a quick interjection because this is something that I completely forgot about when I originally recorded the video. When you enable the firewall for Apache, you also have to make sure you enable it for your SSH connection because by default it will block it, meaning that once you close your SSH connection to Google Cloud, you will lose connection to your server and you cannot get back into it. So what I'm going to do here is this is the sudo ufw app list, and remember we did sudo ufw allow in Apache before. We also want to do sudo ufw allow in open SSH. Now I will put that in the description as well. So we're going to do sudo ufw enable. Yes. And we're going to do an exit out of here. And then we're going to pop back in and make sure that it worked. Because what I was finding was that I skipped over a command initially. I could not reconnect to my server. So we should be able to get back in now. Yes, good. Okay, back to your regularly scheduled programming.